This question says use the table to solve the system. Y equals 5x minus 19 and y equals negative x plus 11. Now, we could just solve this using the elimination method that we've been using so far. So let me show you really quickly how we would do that. So we have y equals 5x minus 19 and y equals negative x plus 11. Now, the y and the y are lined up so that if we were to subtract the equations, they would cancel out. So let's go ahead and do that. If I subtract, I get 0 equals 5x minus negative x becomes 6x, and then negative 19 minus 11 equals negative 30. Now, I just want to solve for x from here, so I would add 30 to both sides, and I get 30 equals 6x, and then I divide both sides by 6 to get x equals 5. Now I could plug that into either of my equations. So we'd get y equals, I'm going to plug x equals 5 into this second equation here. So you get negative 5 plus 11, and negative 5 plus 11, that happens to be positive 6. So that means that our solution to this question is 5, 6. Now, all of that work was really unnecessary because they give you input-output tables for both of these equations. So these values here in this first row, those are the x values. And then in the next two rows, they tell you if you plug in those x values into the equation or function, then those are the output values. So for example, if I plugged in 1 into the top equation, my output would be negative 14. If I plugged in 1 into the bottom equation, my output would be 10. So what you're doing is you are looking for the x value that would give you the same y value in both equations, and that is happening right here. This tells us that if I plug in 5 into both of these equations, my output is going to be 6, and therefore my final solution to this is 5, 6. And that is how we would do this question.